Hello viewers, welcome back. This is MIJ Tech Hacks, and today we are going to pick up from where we stopped. We are going to cover the next part in our module 3, and that is control flow. So today we are going to start with comparison operators. We have been doing this, and we have been using the notes to come up with something or to peruse through this Python full course. And for those who don't know where our notes are found, we go to our YouTube channel. And then we search for our channel, which is MIJ Tech Hacks. On our channel, the homepage channel, when we reach there, we go to a place where there is links. So you come here where there is more, and then go to document files. There are links, the GitHub portfolio, the LinkedIn account, then document files for courses. This is where we click, and then it will take us directly, or it will redirect us directly to where our Python complete course is. And when we reach there, we shall press open. We shall double click for us to open. The files. When we open, we shall find there the Python full course, that is from beginner to professional. Then module 2, which we covered already and did the project. Then module 3, where we are. So those who don't know where to find the notes, this is where to find the notes. So today we are going to look at comparison operators in their full reference. Why do these comparison operators exist at all? Every if condition you've written so far has secretly relied on these. Comparison operators are the tools that take two values and produce a true or false answer by comparing them. Without them, if would have nothing to evaluate. Let's go through these comparison operators. We have the equal to, and what is it really asking? Are these two things identical in value? So the equal to comparison operator is asking, are these two things identical in value? Are these two things identical in value? So this is what the equal to comparison operator is asking. It is asking, are these two things identical in value? Then the not equal to is asking, are these two things different? This is what it is comparing. Are these two things that we are comparing, are they different? For example, if we have 5 and 3, are they different? Yes, it is true. Now in the equal to, if we have 5 and 5, it asks a question, are these two things identical in value? If 5 is equal to 5, then it is true, these two things are identical in value. So these comparison operators be asking questions. They can be asking questions. Like for equal to, it asks, are these two things identical in value? For example, 5 and 5, are they identical in value? Yes, and that is true. Then it not equal to, are these two things different in value? 5 and 3, are they different in value? Yes, it is. That's why the result is true. Then the greater than, let's go to the greater than operator. This one, the greater than operator. It asks a question, is the left part bigger in value? Is the left part bigger in value? So this is the left part, and this is the right part. So it asks a question, is the left part bigger in value? So it is true, 10 is greater than 7, and hence the left part is bigger than the right hand side part, and that's why the result is a true Boolean. Then when we go to when we go to the less than, when we go to the less than, this is the less than sign or the less than operator. It asks, is the left hand side smaller in value? Now look at 3 and 10. 3 is smaller than 10, so the answer is a true boolean. The result is true because the left hand side is smaller in value compared to the right hand side. Then when we go to the greater than or equal to operator, it asks a question. Is the left one bigger or exactly the same? Is the left one bigger or exactly the same? So this one is not bigger, but it is exactly the same. So it must meet two conditions. It must be either bigger or or exactly the same. So the answer is true, because this 5 is not bigger, but it is exactly the same as what is the same in value as what is in the right hand side. When we go to the less than or equal to operator, it asks a question. Is the left one smaller or exactly the same? Is the left one smaller or exactly the same? So 4 is smaller than 6. The condition becomes true, but it is not exactly the same as 6. So one of the conditions of this, if it meets, then the condition or the operator or the comparison operator becomes true. That's what comparison operators do. So comparison operators are the tools that take two values and produce a true or false answer by comparing them. So without them, the if would have nothing to evaluate. So that is it. Then we are going to go further to look at the chained comparisons. This is the part. This part has been highlighted as the Python specific, and Python allows you to chain comparisons naturally the way you would write them in math. For example, if we have if we have this in our code, let's try to go to our VS Code. If we have that in our code, let's try to open our VS Code. If you have something like this, if age is greater than or equal to 18 and age is less than or equal to 65, we are going to print. First of all, we need to define what age is. Remember, in our notes we have age as 25. Let's first of all define age is equal to 25. So they are asking us if age is greater than or equal to 18. If age is greater than or equal to 18 and age is less than or equal to 65, print working age adult. So with this and we already looked at it. And it occurs when both conditions, it prints a true boolean when both conditions have been met. So this condition is asking if the age is greater than or equal to 18 and the age is less than or equal to 65. So the first condition that must be met is you must be above or equal to 18, and if you are above or equal to 18, in that range of you being above or equal to 18, you must be less than or equal to 65. If you exceed 65, then you are not in the working age adult. You are an adult, but you are not in the working age. You are in the age that is supposed to sit home and then relax and then retire from the working industry. So That is it. The and, we saw it earlier that both conditions must be true for the print statement that is indented down for it to run. So that is it. That is it, and that's what we have in our notes. So this is the honest, to trace this the honest way. Python evaluates age greater than or equal to 18 on its own, and the answer must be true or false. Then evaluates age less than or equal to 65 on its own, and the answer must be true or false. Then combines both with and using the strict bouncer rule from the area that we covered. So both must be true. That is the rule. Both must be true. If this is true and this is the true, then Python goes further to evaluate what is in the indented, and that is the print statement. So Python gives you a shortcut that reads exactly like how you would say it in plain English, or write it in math, and that is how it is. That is how it is presented. So this is not the special new rule. Python is quietly doing the exact same two checks underneath. The 18 is less than the age being greater than or equal to 18, and then the age being less than or equal to 65. It is just letting you to write it in clean line instead of stitching to two conditions together with and. So same results, the same logic, and a better appearance. So we have something from our notes. Let's first of all visit our notes and we see. We have something from our notes. We have another example. Score is equal to 75. Score is equal to 75, and then if the score, if score is greater than or equal to 70, but at the same time score is less than 80, then we shall print grade C. Let's first of all have this syntax in our VS Code. Let's first of all have this syntax in our VS Code. Let's get rid of this. So they have told us that score is 75. This is another way of writing. This is another way of writing chained comparisons. Comparisons that are within like two or more comparisons at the same time. So we have score at 75. So this condition must be met, that the score must be greater than or equal to 70, but at the same time the score must be less than 80 for you to achieve a grade called C. That's why score is in the middle, and this one is read as score is greater than, because score is on the right hand side, so we read it as score is greater than or equal to 70, but at the same time score is less than or equal to 80. If we are reading while going to the left hand side, we take the opposite of that sign. If it is less than or equal to, we take it to be greater than or equal to. If you are reading when we are reading from the left hand side to the right hand side, if you are reading when we are reading from the left hand side to the right hand side, we take the signs, we take the operators as they are. But if you are reading from the right hand side to the left hand side, we take the opposite of the given operator. Now in this case we have less than or equal to. Because we are reading from the left hand side to the right hand side, we shall take this as greater than or equal to. So score must be greater than or equal to 70, and at the same time the score must be less than or equal to 80 for you to print out this statement. Let's first of all print to the terminal and we see whether this prints. Remember, our score is 75, so the condition will print grade C because it still lies in this, because score must be greater than or equal to 70 and score must be less than 80. So 75 is greater than or equal to 70, and at the same time 75 is greater than 70, and at the same time 75 is less than 80. So this should print grade C. So let's try to see in our terminal. So it has printed grade C, like as we have seen. Let's try to change and see whether and put 60. Let's try to put 67. Will it print? Let's try to see. Let's try to see whether it will print something. So it will not print anything because because 67 is less than 70. So one condition being false makes the whole sentence false and nothing gets printed on the terminal. So so that's how we go about that, and that's how we chain comparisons in Python. And that's how we chain comparisons in Python. So that is it, and I hope that someone has appreciated. So there is something that I would like us to untangle. There is something that I would like us to untangle. It is not in our notes, but if we try to compare this logical operator equal to is equal to, it behaves differently depending on data type, and comparing values of different data types can silently produce results that you don't expect. For example, if you have something like print 5 compared is equal to print 5 is equal to 5. Print this comparison is 5. Let's try to see. We are going to print this. Are these two values identical in values? Print the result of comparing 5 and 5. Are these two values identical in values? Let's try to see what it prints. It prints true. So it gives us a boolean which is true, because after comparing, are these two values identical in value? Is 5 identical in value with 5? It prints true because 5 is identical in value with 5. Then let's try to compare this also. Let's try to print this with a different data type. We have up here we have compared an integer with an integer, but now we are going to compare with an integer with a float. Print 5 compared to 5.0. Let's try to see what gets printed. It is true. So when we compare 5, which is an integer, and then 5 as a float, it gives us a true. But what of when we compare 5 when it is in a string? So we shall have it as print. Are these two values identical? Are these two objects identical in value? Let's try to put 5 as a string and then compare it to 5 as an integer. Is 5 as a string the same as 5 as an integer? False. So some people may this takes us back to our module 2 that has type conversion, meaning that a string which is 5 and a 5 that is an integer is not comparatively equal in value. So you must undergo type conversion, like as we covered in module 2, for you to come up with the comparisons that are consistent. So I think someone has noticed that when we compare a 5 that is a string to a 5 that is an integer, it will give us a false value because those two are not identical in value. So you need to always take keen note of that. So with that we shall go to our notes. And we see what we have next on at the end. So we have the while loop. So by definition we have the while loop. So by definition, a while loop repeatedly executes a block of code as long as a condition remains true. Every time the block finishes, Python checks the condition again, and when the condition becomes false, the loop stops. So the while loop will always repeatedly execute the block of code as long as the condition remains true. And every time the block finishes, Python checks the condition again, and when the condition becomes false, the loop will always stop. For example, the basic while syntax, we have it as the while condition. The body runs repeatedly as long as the condition is true. Then, for example, we have counting from 1 to 5. Count is equal to 1 while the count is less than or equal to 5. So this condition will run until the count is less than or equal to 5. If it is less than 5, it will run. If it is equal to 5, it will run. But if it goes above 5, it will not run. So let's try to get through this example. Let's try to get through this example in our VS Code. Let's try to get through this example. So we have it as so guys, you need to appreciate that every time we've covered everything that we have covered so far, the if, the and, or, not, comparisons, lets a program make a decision one time. But think about real problems: asking a user for a password until they get it right, printing every item in a shopping list, calculating a running total from unknown amounts of input. None of these have a fixed known number of stops, the steps decided in advance. You can't write 50 separate if statements and hope it is just enough. So a loop solves this by saying, keep repeating this block of instructions, checking a condition each time until the condition becomes false. It is the difference between telling someone to check the door once versus keep checking the door until it is locked. So the core mental model, if we have our syntax like in our notes, something like this. If you have count is equal to 1, then while the count is less than or equal to 5, this problem or this loop is going to continue running until the condition becomes false. So if it is 1, it will run. If it is 2, it will run. If it is 3, it will run. If it is 4, it will run. And if it is 5, it will run. But if it becomes 6, the condition becomes false, because the condition will always run while the count is less than or equal to 5. And up down here, the while loop will always have an update, because if it doesn't have an update, the condition will run indefinitely. Because if it will always compare the one, then that condition will always remain true. So the while loop will always have an update. That's why we say that count is updated as count plus 1. Each time it runs, it is incremented by 1. So one of the things that you must note is with the while loop, we don't know the number of times the loop is going to run. And the loop will always run until the condition becomes false. Then the while loop should always be updated. If it is not updated, it will always run indefinitely. So this condition will always, it will print count, it will print 1, it will print 2, it will print 3, it will print 4, and then it will print 5. On reaching to 6, the condition becomes false, and the loop will stop. So that is it. It will print 1, 2, 3, 4, and then 5. I hope someone is understanding, and I hope someone is following along. So that is and that is it, and this is how we trace it. So Python creates count as a variable, and then and stores 1 in that variable. So Python creates count and then stores 1 in it. Then Python reaches the while count, which is less than or equal to 5. Python reaches this step, the while count, which is less than or equal to 5. This is a question, exactly like an if condition. It evaluates it to true or false. It asks, it first of all looks at count as 1, and then asks, is 1 greater than, is 1 less than or equal to 5? The condition is true. So it will evaluate and then print that 1. Because the condition is true, Python runs the indented block and prints 1, then runs count is equal to count plus 1. So count becomes 2. Before the loop, so it goes down and then counts, updates count as count is equal to count plus 1, and then count now becomes 2. So it goes back and then compares. Is 2 less than or equal to 5? Then if yes, because the condition is true, so the 2 goes and then it is printed. So here is the critical difference. If from if. This is the critical difference from if. Python does not move on. It goes back. But if it was the condition, the if condition, it will just stop there, because the condition has been met and it is true, it will just stop there. But when it comes to a loop, Python does not move on. It goes back up and rechecks the condition again. Is it 2 less than or equal to 5? Yes. Runs the block again, prints it 2, then count is updated to 3. Then again it asks, this repeats the checks condition, true runs block, then checks the condition again, true runs block again. Eventually count becomes 6. Python checks, is 6 less than or equal to 5? No, it is false. So because the condition is now false, Python does not run the block this time, and instead jumps to whatever comes immediately after the loop, if there is anything at all. So this single sentence to keep forever while re-asks the same question over and over before every single run of the block, and stops the instant the answer becomes false. The part that separates a working loop from an infinite loop. We are going to see how do we differentiate between a working loop from an infinite loop. When you look closely at line 4, count is equal to count plus 1. This is not just a decoration. It is the only reason the loop ever ends. This is the only reason the loop ever ends. The condition count is less than or equal to 5 only becomes false if something inside the loop actually changes count. If you forget that line entirely, let's try to see. What if we get rid of this count is equal to count plus 1? What if we get rid of that update? What gets printed? What? So we see that 1 will always be printed. It will always be printed, and it will never ever stop. So that will be an infinite loop, and infinite loops are not useful. So when you trace this on a string, count is 1, condition is true, block runs, prints 1, 1, 1, 1, 1, and then Python goes back to check the condition again. But count is still 1 because nothing has changed. Condition is true again, prints 1 again forever. So this is called an infinite loop, and it is listed as common mistake in our notes for a good reason. It is probably the single most common bug beginners create with the while loop. So the fix is we shall press Ctrl plus C in the terminal and it stops the program. But the real fix is making sure something is inside the loop, and the loop is always updated. So the 3 recurring patterns worth understanding deeply or not just recognizing. Your notes list these as separate examples, but they are really the same idea, wearing 3 different outfits. Understanding the shape matters more than memorizing each one. Pattern 1, the counter A. Pattern 1, the counter. We shall have the counter. A variable ticks up or down by a fixed amount each time, purely to control how many times the loop runs. So count down, if we have something like count down. So we have the counter. If you have something like count down, countdown is equal to 10. Countdown is equal to 10. So while countdown is greater than 0, we have this in our notes. While countdown is greater than 0, print f string countdown. Print f string countdown. Print f string countdown. And then the part that is very crucial, the update part, which is countdown, is equal to countdown minus 1. Or someone could say, just say minus equals 1. So this is the same as countdown is equal to countdown minus 1. So when we print this, of course, it will first of all check, is 10 greater than 0? Yes, it will print 10. Then subtracts a 1. And then asks, is 9 greater than 0? Like that, until it reaches 0, which is not greater than 0. So it will stop on 1. So let's try to print and see. So it will be 8, then 7, then 6, then 5, then 4, then 3, then 2, then 1. So when it reaches at 0, 0 is not greater than 0, so the loop will always stop. So what you need to note on the while loop, the while loop will always run until the condition remains, until the condition becomes false. And we don't know the number of times the while loop runs until we set something that is going to make it false by updating it in every run. So the update part and the counter part are always necessary for the condition to not fall into an infinite job. So the counter's only job is counting iterations. It is not collecting data, it is not representing anything in the real world. It exists purely to eventually make the condition false. So the reason as why this counter exists, it is existing to make the condition false at time t. So pattern 2 is the input validation. The loop's job is to keep rejecting bad input and asking again until the user finally gets something that is acceptable. For example, if we have something like this, if we have while the password is not equal, if the password is not equal to Python 123, then this loop is going to run until the password is equal to Python 123. So while the password is not equal to that, password is equal to input, enter the password. If the password is not equal to Python 123, print wrong password, then try again. print access granted in case the Python is equal to that. So this condition, this check is going to always run, and we shall always print wrong password, try again, if at all this condition is not met of Python, of the password being Python 1, 2, 3. Let's try to run this and see. Enter the password. Let's try to put Python. Wrong password, try again. So we shall always keep trying again until the wrong password is until the right password is entered. Now for there are limitations. If we can also put other limitations. If you try again more than 3 times, then something is blocked, but we shall go, see that in the later process. But this program will always keep on asking you the password, and if you type in the wrong password, it will present a message that this is the wrong password. Please try again by entering the right password. And let's try to see if we enter Python 1, 2, 3. It will print access granted because it compares with what it has. And if the condition becomes true, the loop is closed or the loop is terminated, and then what gets printed is that is immediately after the loop. So that is it, and that's how we could go through it. So the next pattern is the accumulator. The loop's job is to build up a running total, a collection across the repeated until and across the repeated inputs until a stop signal is given. So for example, if you have something like total is equal to 0, if you have something like total is equal to 0, then number is equal to, if you enter the number with input, enter a number 0 to stop. While the number is not equal to 0, total is updated as we shall be increasing the number. So number is equal to enter a number that is 0 to stop. So print total sum as total. So we shall see. Let's try to put any other number which is not 0 when we try to run our program here. Enter a number 0 to stop. So when I enter 0, it will stop and print the sum of the numbers that I've printed. So let's try to enter fancy. Enter a number 0 to stop. It will always ask that question. When I enter 0, it has printed 9. So the total sum of the numbers that I've entered is 9, and 0 is to stop. So this one is going to calculate the total number of numbers that I've entered until I type 0, and then it will represent the sum of those numbers that have been entering. So that is it, and those are the major 3 patterns. So when you note something a beginner easily misses, the input is called twice in this code. Once before the loop starts to have something to check for the very first time, and once inside the loop to get the next number each round. This duplication is intentional and common in this pattern. It is called priming the loop. So something that our module not gets at and don't fully explain is the while true with break. So this one, let's try to see what the while true with break. This one is not explicitly covered in our notes, but it is very essential. So we have something like this in our code. The while true with break. So while the condition is true, answer is equal to input type quit to exit. So if the answer is equal to quit, then the loop will break, and then it will print program has ended. So I want to explain why this pattern exists. Since you're not show it but don't explain the reasoning, while true means the condition is always true by itself. This is guaranteed. This is a guaranteed infinite loop deliberately. So how does it ever stop? It relies entirely on a break statement inside the block inside the block to forcibly exit. This pattern is genuinely useful when you don't know in advance what the condition should look like until partway through the loop's own logic. So we just recognize the shape, the while true, then an if plus break inside the loop until something inside decides to stop it. So one thing worth flagging that isn't in your notes at all: the condition in a while loop is checked only at the very top before each run. This means that if something is inside the loop, if something inside the loop changes a value in the middle of the block, the loop won't notice until it finishes the current run and comes back around and check again. This matters later when you are debugging. The loop should have stopped already. So it is not a bug, it is how to check, then run the cycle, and then the cycle works. So that is the while loop fully unpacked, and I think we shall stop here when we look at our nodes. So that is the count pattern, the counter pattern, the input validation pattern, then the accumulator pattern. We have covered that. So the infinite loops, and we have talked about this where the while loop. So that is it, and in our next tutorial we shall cover the for loop. See you in our next tutorial. See you in our next video. This is MIJ Tech Hacks, and this is MIJ Technologies. For those who don't know where to find these notes, please visit our YouTube channel. When you visit our YouTube channel, go to where there are more links, then go to where there are these links of document files for the courses. You'll find there our document files, including the full roadmap to Python, and then the module notes that we use to cover this. MIJ Tech Hacks, MIJ Technologies. See you in the next tutorial as we come back.